So welcome friends, and I'll make this very short video. In this video I will tell you how to draw a cyclohexane chair form in a very efficient and good way, because cyclohexane chair form is not only important for drawing any cyclohexane derivative. If you learn the reactions, pericyclic reaction, other reactions, aldol reactions, you know that many reactions goes through this chair like transition state. So you should be familiar and should be capable of drawing this. So the simple way of drawing cyclohexane chair form is, first draw any point here. So let's say you have a point here and draw an angle like this. Okay, now from these 2 points add two lines which should be parallel to each other. You can see these two lines are parallel to each other and their length should be same. So this length and this length should be same. You can see these are same. Now draw again this. So right, so this and this. So now you can see these two, this line and this line are parallel, also these and these are parallel. So you have to be careful that this parallel relationship should be retained. So these and these are parallel. Now this is a complete chair form. Now you have to add the substituents. So for the axial substituents, you can imagine a axis here, and these axial substituents are all, so you can, if you draw an axis here, these axial substituents all are axial parallel to this axial group or this axis. So this way you can draw these axial substituents. Okay, now the axial substituents are complete, so I can represent it a, here again a and another a. So these are the axial substituents. Now it is time for equatorial substituents. For the equatorial substituents, you have to be careful that when you are drawing a equatorial substituents here, it should be parallel with this group. So the opposite two should be parallel, and when you are drawing a equatorial substituent here, it should be parallel to this line. So it will be like this, equatorial. Now when you are drawing here again, it should be parallel to this, and when you are drawing here, it should be parallel to this. So in this way you can, and one more left. So here you have another equatorial group, and here you have another equatorial. So you can see these groups are also, this is parallel to this. So opposite groups are always equatorial parallel. So this is parallel to this, and this is parallel to this line. These two are parallel. Now you can remember, after drawing, you can also remember that if the parallelity is there or not, you can check. So you can see there is a W. So a W is there, W relationship between these two equatorial groups, and this position is there, and also a M relationship is also there. You can see this M and this W you have to find out, and then you can confirm that your structure is completely right, because many people draw equatorial substituents like this. This is completely wrong. Okay, and also another mistake is that some people draw this thing flat like this. So this is again not a correct representation, because here you cannot denote the axial and equatorial correctly. So this is the correct way to draw a cyclohexane ring. I know most of you know how to draw, but it is for the beginners who are just joining for chemistry and struggling with drawing the cyclohexane ring. Also, this thing I learned from the Claydon book. You can find in Claydon. They explain this very nicely.